And only after you explained it, I was like, oh, wow, this is probably going to be one of the biggest new features in terms of performance. Today we're talking about hydration.
What is it?
What is it?
What is it? And why is everybody talking about it? No, okay.
Is everyone talking about it? You gotta tell me. Yes. I heard about this hydration thing just a week ago. I was like, how did I not know about that? Okay, I'm not coding every day anymore, but you certainly are, Dominic.
Yes.
For the rest of us, what is it? Hydration and JavaScript loading strategies.
Okay, so that's again a big topic and quite a lot of things to cover here.
It's always a big topic.
No, but like in general, I mean, in the JavaScript space, people are talking a lot about hydration and different hydration strategies. Let's put it that way. Because why don't we know about? Why don't you know about it? Because back when you were doing most of your development work, right? jQuery was like the thing, and you didn't think about it. You rendered stuff on the server with PHP, and then you had jQuery to do the interactive parts, right?
Or prototype, yes.
Or prototype, yes. Or
that's way back.
MooTools. So. And there, this question doesn't really arise, but this whole this terminology, it all comes from well, first of all, single page applications were introduced first, right? And then JavaScript moved from the client to the server, and then you wanted to do isomorphic JavaScript, and then the thing was you always shipped a lot of JavaScript across the wire for your entire app, and even if you didn't need all of that. And while the server now can actually render or renders JavaScript as well, as long as you have a Node.js server, it's you want to basically control what kind of JavaScript code is executed on the server during rendering and during server-side rendering, and what JavaScript is executed on the client to make things interactive in the browser. And that's where the term hydration comes from, because what you do is you pre-render something on the server, send across the HTML, but also send across some JavaScript where you actually want to pick up then at a state where the server left off, sort of, right? So you hydrate your website. And then there are a lot of different or different strategies, different types of hydration, right? So there's the full page hydration where you just basically hook up your entire site with JavaScript. Then there's partial hydration if you reload stuff, or if you just want to do certain areas of your hydrate certain areas of your page. And then there was a concept that is called islands. That is also really popular and kind of the next evolution of partial hydration. And this basically means that for every, if you think in components, for every component, you can decide yourself if client-side JavaScript should be executed and also loaded on the client. And then there's some other stuff as well, which is resumability, which is a different approach. And there are certain JavaScript frameworks that are experimenting in these directions. And most of them also have something that is called a meta framework, right? So a meta framework is something the most popular one is probably Next.js, where this combines some client-side technology, some JavaScript frameworks to be used for also either statically generated sites for server rendered side, or there's also the term incremental static generation. There are these SSR, SSG, ISR, and sure. It's all if you don't if you don't deal with that on a daily basis, this can be totally overwhelming. But the question, of course, remains why are we dealing with this, right? So why do we care if we are still using WordPress, a PHP application, and not Gutenberg React components, but we basically still have our traditional setup with like server-side rendered HTML, and then serve JavaScript and CSS like bundled in a certain way, right?
Exactly, because like we're doing it like that, because I remember when we released, or before we released Flint version 1.0, before that, I think in a 0.9 version, I think we were still loading also JavaScript assets for components one by one. We loaded them separately because we thought the advantage of using HTTP2, of having multiple requests handled like asynchronously by the server or in parallel, that there would be huge benefit. However, when we did the final release planning for Flint version 1.0, we made some PageSpeed and local performance tests and server performance tests on the loading and execution behavior. And we experienced that actually bundling all the component JavaScript was overall quicker in the overall loading behavior of the site, unless that would be a very extreme case of a lot of JavaScript. And so it felt a little bit like a step back then. But yeah, we said, okay, but if that's the best approach, we have to go that route. And now all of our JavaScript typically is bundled in case, or just in other cases, or there might be cases where we optimize for that for larger sites. However, over the course of the past 3 years, also the metrics for PageSpeed and Core Web Vitals changed, improved, and so on. And especially also the JavaScript loading time and execution time became one of the biggest challenges to optimize for in the past, and one of the biggest influential figures to rather negative PageSpeed scores. And that's why we challenged that again and said, what's the future of making JavaScript loading and execution effective?
Yes. Yeah, you're totally right. Like, basically, I mean, it wasn't a bad thing, like splitting up the components into like each like its own parts, right? But the strange thing was always a little bit, we used a bundler, like a JavaScript bundler, in this case, like it was Webpack, to actually treat the component JavaScript files as separate files or as separate entities. Basically, everything was its own library, sort of, right? And then we generated that, and we included all of the JavaScript files that were loaded on a page. So this was like the improvement. We didn't have to load all of the JavaScript, like from every component on each page, but we could look at the page and say, okay, these components are on that page, so we need to load these JavaScript files, right? And this was definitely like with that, the overall amount of JavaScript that we loaded decreased, but because we had multiple script tags that need to be parsed and executed separately, because and because more requests needed to be done, for like 90% of the websites that we do, or a large number, like maybe it was not 90, but maybe 80%, right? It was faster. We had better page speed scores for loading just one single JavaScript file of every component, like with the code of every component. Like, of course, in a modern way, like not render blocking in the head, but like maybe deferred, in a deferred way. So this was number one. So back then we were doing kind of full.
I just want to add like the caching advantage of that also.
Yes.
Right?
Yeah, like especially like, I mean, that's one of the things that isn't really considered when doing page speed analysis, right? So page speed tests will usually be a one request thing. So if you have like an empty cache and so on, but for like subsequent site visits, well, actually there wasn't a big cache advantage because we had the components broken up separately, and this also could be cached, but the thing is you didn't need to load any other JavaScript. Like you only needed to load one JavaScript file for the entire site, and this could be reused, right? So this was cached with the initial request, and then you didn't have to do any more requests for other sites, right?
Yeah, and if that was just like, let's say 50 kilobytes, 100 kilobytes, 200, whatever, like in that range kind of, then likely the advantage of loading that once and was quicker than making the extra round trip requests for every new page. However, at the same time, we probably mostly looked at loading time also, and I think the parsing time also got more and more significant, also probably with more complex libraries and so on. But yeah, that was part of the strategy of saying, okay, it's also cached for subsequent requests. And I think this was before Core Web Vitals were a thing. And then somehow that Core Web Vitals went into the same direction, because those are taking multiple site requests most likely into consideration.
Yeah, it's all about like when like the page being interactive, right? So how do you ensure that the page is interactive, or like the faster it is interactive, the better your scores, right? And this wasn't really measured before, I think.
Yeah.
So, and maybe like you notice now, like we were loading all of the component scripts always on page load, right? So this was like the thing, because back in the day, this is basically what is full page hydration, right? So we loaded all the JavaScript that we know we need on a page, like either like even more with like the bundled approach in like a single file, or with like the component, like separate files for components. And we always did tests, and like, yeah, and we decided to stay like, I mean, for bigger clients and bigger websites, we opted out of this this approach, and we actually loaded all of the components JavaScripts like separately, because this just resulted in better scores, right? So, but what can we learn now? Like in the next release of Flint, which is unfortunately not yet released, but it's available publicly in the Flint repo on GitHub in the next branch. There we thought about like the entire structure, or the entire concept of architecture of the loading again, and wanted to make use of some of these more modern techniques, right? So, because what is really like, and like the biggest improvement that we actually saw, to make things short now, is that the biggest performance improvement can be done if you only load the JavaScript of the components that is actually needed for the current viewport, right? For the current view, like so
scrolled viewport.
Yes, and this is the concept basically of islands, right? So we basically for every component we say, okay, you load the or every component that has JavaScript, we say there is a different loading strategy, right? So we say this component needs to load basically needs to be loaded immediately, as fast as possible, right? For example, like this would be something.
So we could say kind of the default behavior would be similar to it is right now, but still optimized in terms of we don't load for each component. Each component has its own JavaScript file, but we don't load that on page load. But we determine which components are on the page, and then we could, as soon as the page, the DOM is loaded and ready, we could load the JavaScript for the components that are on the page and execute them. That would be one step of optimization that would ensure like faster page load already. But then you can improve from there, right? You can then also say that's the loading behavior, what you're describing, about what are the other options. Only load the JavaScript even when the component is scrolled into viewport?
Yeah. So, like, what kind of JavaScript do you need for a component? Like, or when do you need the JavaScript, right? And usually, like, we develop our components in a way that JavaScript isn't needed to, like, JavaScript is basically only progressively enhancing the things, right? So, or at least the layout is not broken if you don't load JavaScript. And this is something important to always take into consideration, right? Because otherwise you would need the JavaScript for the whole page to be correct. But this, like we always try to ensure with CSS and the markup of our components. So what the improvement is of like splitting up, because, okay, sorry, I'm a little bit, I lost sort of the connection to the previous question, but basically when
I think I interrupted you about the loading strategies.
Yes.
So I was just trying to make sure like going from kind of the basic idea to the further improvement. So the basic idea is, or concept, or an improvement is that you can only load the JavaScript and execute the JavaScript for those components which are on a page.
On a page, exactly. That's full page hydration, yeah.
Yeah.
So exactly. So the and again, we said like we tried this in the past and it didn't really give any improvements. But we tried it in a way where we split up the components sort of in the build process, right? Because the tooling wasn't so good back then either. So what we do now is we basically we have one build process, like one entry point, and from there we have a function that checks what kind of components are on a page, right? So this is a bit more dynamic. Before we always had to specify what component, what JavaScript needs to be loaded inside of PHP. So when one component was added with a PHP rendering onto the page, we said, okay, now also enqueue these assets. And now this is done, or the first step we did was we said, okay, we don't do it that way, but we check actually the DOM for components that are available. This is also then an improvement because when you asynchronously load HTML and add it to the page, like a load more button or whatever, right? Or like some other AJAX request that puts in page content in the page, we would actually, because we were using a mutation observer, like observing the DOM for changes, like check, is this a new component where code needs to be loaded? And if so, we just load it from the server, right? Via like integrated, like in this JavaScript ecosystem, via dynamic imports, right? So, and this already worked out quite well. Like there we had like some minor improvements, right? But the next thing we then, like, because this was still like full page hydration kind of, or no, this was more like partial hydration. Let's put it that way, I guess. And then we decided, okay, what, instead of just checking the entire DOM, let's take only into consideration the current viewport, like the part of the page that is visible to the user, and just check what kind of components are there. And those that are visible, for those you only load the JavaScript. And in addition, like this is okay for most things, but there are some edge cases, right? Because, for example, a sticky or fixed or sticky header menu that is on the page, if you have scrolled down, this is not like officially kind of in the viewport. And you, if you want to like load a JavaScript script, like we use headroom on most of our sites, like this wouldn't be loaded then if you weren't at the top of the page, right? So we needed to have a way of also saying, okay, this is a component that is so important, like that is independent of the viewport. Load that either like on, for example, on page load, or like so immediately when this is when this is found, or on idle. And idle just means there's a function like a request idle callback, for example, so you can tell the browser only when you're free like when you have some free time, when you're done with the important work, only then load the JavaScript, right?
Okay.
Yeah. And like this is basically the island approach, and this has led to like amazing increases of page speed scores for us, because how many components can you have on a page, right? So I mean, you always have like the navigation. Maybe there's like one or two other like global blocks that need to be loaded immediately. But other than that, like depending on your viewport, you have like 1, 2, maybe at the maximum 3 components that are visible on a page, right? So you only at most load like 5 to 6 JavaScript files that are external.
On initial load, kind of. And then when you further start scrolling down, then extra JavaScript is loaded, executed.
Yes.
How fast is that? When does that happen? Extra JavaScript loading, execution. Like, will I then sometimes see that something is popping in?
You might see that, like if somebody scrolls quickly through your page, right? For example, we have like on our homepage, which uses an older version of this approach. So we fine-tuned that for Flint next. We have like a button with a badge, and this badge loads some data asynchronously, right? So there you actually notice when you quickly scroll to the footer that the badge pops in a bit later, a bit delayed. But actually, I think this is also a feature.
It can be also a feature. Like it's like little ping, look here. Yeah.
And you can also like you could also use that, like before we always had to add additional like intersection observers to components that have like a loading animation, right? Where the content needs to fade in. So, and for that, you wouldn't need to write any extra like code now, because you can take care of like the global, like you know this component will only be initialized once it's in the viewport.
That's cool. I didn't think about that. So yeah, that opens up some new creative ways of using that also. And for this batch, like if I don't want things to visually pop in, I could also just change the loading behavior of that component, say it should always be directly loaded or on idle or whatsoever. Right? There are these 3 approaches. What was the first one? Load immediately? How did you call that?
This is on like on visible. No, on like the immediately is on load.
On load.
Then there's on idle.
On idle.
And on visible is the other thing that we have implemented. And we've implemented one more thing, which is called on like load on media, basically. So that actually, and you can combine that with the others. So that means load the JavaScript of a specific component only when a certain media query is met. And this is also like super nice, right? Because if you have and a lot of the times you do have a different menu for mobile than you have for desktop, and maybe you like for the burger menu on mobile, you need some other JavaScript libraries, and then those wouldn't be loaded on desktop. Or the other way around, if you want to have like a fancy like this headroom stuff on desktop, and on mobile you just go for a simpler route, then you wouldn't need to load that JavaScript on the desktop. So this is actually
nice.
Pretty cool. And I mean, we took a lot of inspiration from other libraries, and especially like from Astro, which like popularized. I guess they were not the first to come up with this island approach, but they, for me at least, popularized it. And then it's funny how like afterwards, after we've implemented this, we actually found some other libraries as well that are pretty close to what we are doing. Like for example, from 11t, there is the isLand, like island, like isLand web component that actually does this loading as well, but sort of in a different way, because this is more suited towards like finished components where you have like a clear URL that you want to import. For us, we integrate that in our build process, right? So we actually make use of dynamic imports that can also, where you can have like string concatenation of components. So like have a dynamic import, like a real dynamic import with a variable. that we can use to actually load this code. And this is like for our build process, like super, super awesome.
Yeah. So we're not using a library. We were inspired by a library. Is this approach? How do you use it? How will we be able to use it? How will developers be able to use it and apply it?
Yeah, there's a one missing part that I didn't talk about, and this is like, how do we, I said a mutation observer, and I say we're watching the DOM and so on. And there are like several approaches and also like some really nice libraries that help you do that. There's, for example, from Web Reflection, which is a single developer who does a lot of open source. There's a library called, I think, QSA, where you can just watch the DOM for certain selectors and then execute some code. But we decided for now to go with a more integrated approach that doesn't need any extra libraries, because we're trying to cut JavaScript as much as possible, right? Mm-hmm. So, and web components actually have this functionality. So that means whenever a web component is found in the DOM or inserted into the DOM, some JavaScript is executed. And whereas in the past, like we wanted to move away a little bit from web components because they required a lot of like boilerplate to write the stuff that we wanted, and we always like we actually didn't have a lot of a JavaScript logic where a web component would be helpful for, right? But the loading mechanism of a web component is pretty nice. So what we're doing actually now is, instead of having a different like I'm saying web components, but I mean custom element, right? So this is one part of the web component spec. So we're only using custom elements. Before we had basically for every Flint component, right? We had a custom element, or at least for every Flint component that had JavaScript. And this then specified like the loading or like the connected callbacks, like when it's added to the DOM, like what code should be executed and so on. We moved away a little bit from, and we used built-in elements. So that means we extended built-in elements. We extended like the navigation. If we had like our Flint navigation was a nav element actually, to get like the semantics and get all of the behavior out of the box. And there is a problem with extending built-in elements, that this is not supported across all browsers, right? So there's still like Safari issues and so on. And the question is if they're ever going to support it. So for that, you needed a polyfill to do that. And again, we want to cut down on JavaScript. So we are ditching this polyfill. And we actually now don't have one web component per Flint component, but we have one wrapper component, and this this custom element is called Flint-component, right? And this component basically implements all of this loading functionality. So you can have like attributes there. Like, we are not 100% sure on the naming yet, so this might change. First, we took it, like as I said, from Astro, but I think we might go with a different naming approach. So like basically you can add attributes like load on, for example, visible, load on idle, load on
in the HTML, right? You write a Flint component, and then you can add an attribute, HTML attribute, like load on. Yeah, what was that? Idle.
Load on idle, load on visible, load on load.
Load on media.
And load on media. And like maybe there's also like some other things like load on interaction. So when you scroll first or something like that. So this could be added as well. And then you need to specify the name of this component, right? So currently we use the attribute name. We could also use like an is attribute or something like that. But yeah, or like where then our JavaScript like build tool, which is Vite now, knows, okay, this component, that's the component name. Now I go and look in the components folder should be a directory with that name and then a script.js file. And if this exists, I load it. And if it doesn't exist, I don't do anything. And then we have to because they are not web component or custom elements anymore, we only instantiate or execute the code inside of the JavaScript file from the component. We only execute that in the connected callback of the custom element, right? So that's a little bit complicated maybe, but that's just the logic behind it.
Okay,
and,
but for clarification,
yes.
the loading of the JavaScript happens only based on the condition, or it always happens immediately?
No, that's the thing.
Only on the condition.
Loading the file happens on the condition. That's why you need some sort of wrapper. You always need a wrapper for that. Either an external library where you look for directives inside of the DOM completely, or you have one single custom element that takes care of it. And yes, this introduces maybe a bit of overhead DOM element wise, right? So, but still, for our approach, this is not necessarily a downside, or we haven't seen really big issues with that, because usually we're replacing, we are not introducing other custom elements inside, only in the navigation that we now have to wrap with another element. But for the others, we just got rid of one div and added this component. And so this is
great.
This is super nice.
That sounds amazing, and I've seen the first results, who also look very amazing on our own website, right? And also the next, I think on the next .flint test website, when we currently run a PageSpeed test, it gives us on mobile 100 out of 100 consistently. I find that really pretty amazing, because usually that there was no way that would be possible, mostly because of all the JavaScript execution time and time to interactive. Yeah,
and I've seen in experiments that were the JavaScript parsing and execution or whatever took 10 milliseconds. So I'm okay, you don't need to do anything here. And this is super cool.
Great. Yeah.
There's tons of things I could probably add. But
I think I was, when you first presented that, I remember I was rather skeptical. I was like,
yes.
What is this? I don't get it. I don't understand it. Well, people get it. Do we need this? And only after you explained it, I was like, oh, wow. Yes, this is probably going to be one of the biggest new features of the new Flint version. Biggest improvements in terms of performance, right?
Yes. One thing that I just wanted to say, because it doesn't prevent you, right? All of this, the Flint component is just a wrapper for loading JavaScript, for loading external stuff. So inside of that, you could still use a web component or whatever, where the code of the web, the definition for this custom element is specified inside of the component's JavaScript file. So this makes it it makes it really super intuitive, actually, or simple and straightforward.